Hi, well, we are going to talk about the properties of matter, okay? As you know, matter is anything that has mass and takes up space. Everything around us is matter, including things that we cannot see, such as air and microbes. Recall that matter with a uniform and unchanging composition is called a substance, also known as a pure substance. For example, salt and water. Salt is composed by sodium and chloride, but water is composed by hydrogen and oxygen. To look at this, for the seawater is not a substance because samples taken from different locations will often have different compositions. So the salt is made by the combination of two atoms like sodium and chloride. Okay. Meanwhile, the water is composed by two atoms of hydrogen and one of oxygen, only one atom of oxygen. And this is important because we're going to talk about the three different matter states, okay? So matter that exists naturally on Earth can be classified as one of these physical forms, which are called states of matter. Each state of matter can be distinguished by its properties. So for the beginning, we're going to talk about the solid, okay? But a solid is a form of matter that has its own definite shape and volume. That is important, okay? Solid, definite shape, and volume. We have, I don't know, 3 examples over here, like wood, paper, or sugar, okay? The particles of matter in a solid are tightly packed, as you can see on the figure that I draw over here. I'm gonna show you a picture. Let me see. I'm gonna show you a picture about the states of matter, particularly solid. So look at this, okay? We have a cylinder, and we have here, for example, we can choose neon, argon, oxygen, and water, okay? For example, oxygen, okay? So let's remember this important thing. You have the cylinder, yeah? Okay? Inside the cylinder, we have a solid, okay? A solid made of oxygen. So look at this. The oxygen, the solid oxygen, has its own definite shape. I don't know, for example, it's a cube. And has its own volume, okay? And if you can see each particle on the animation, each oxygen particle are tightly packed between them, okay? There is no enough space between atoms. Okay? That's the principal reason why the solid has its own shape. Okay. The tight packing of particles in a solid makes it incompressible. It's an important thing. Incompressible. So a solid has a definite shape and does not take the shape of its container. Okay. That's the important thing about the solids. Okay, let me see. I will show you another one over here. It's opening the presentation, so just will take a second. That's it. So look at this. Look at the presentation we have here. So for example, we have here the 3 different states of matter. So solid, the 3 pictures over here are the 3 of them are water. So we have solid water on the left, at the center we have liquid water, and to the right we have the gas or steam. For the picture of the right. Okay, so look at this. At the left we have the solid ice. Look at the form. It's a cube. Okay, but if we look at the center of the picture, we have the liquid form, and the liquid form, it doesn't have the cube shape from the left picture. Okay, so we're going to talk about the liquid. Okay, let's go. I have the liquid. Let me see. Okay. Liquids. Okay. A liquid is a form of matter that flows, has a constant volume, and takes the shape of its container. So for example, we have here water, blood, and mercury. Okay. Recall, mercury is the only metal that is liquid at normal temperature. I don't know, normal temperature will be 20 degrees, for example, 20 Celsius degrees. Is the only one that is liquid. Okay, I will show you a picture. Let me see. I will show you a picture on liquid mercury. Okay, it'll take only 2 seconds to open the picture and show you. Okay, let me see. I will show you right now. I'm looking for mercury. That's it. I will share my screen with you. Okay, that's it. Okay, we have here the mercury. Look at this. Look at the picture on the left side. Okay, that's a liquid form of pure mercury. Okay, and this metal melts at minus 39 Celsius degrees. Okay, and the solid mercury, come on, read the the orange circle on the left, solid mercury is soft enough to be cut with a knife. Okay? Oh, that's nice. It's a interesting characteristic of the mercury. Okay, and the principal use that we have from liquid mercury are the thermometers. Okay, inside the thermometers we have mercury and liquid state. Okay, so we have here the thermometer. Excellent. Okay, so the particles in a liquid are not rigidly held held in a place, okay, and are less closely packed than the particles in a solid, okay. So there is like a space that is bigger than in a solid configuration. Okay? This property allows a liquid to flow and take the shape of its container, although it might not be completely fill the container. Okay? And remember, liquids are incompressible. Okay? So a liquid will show you that screen. Liquid has a definite volume, but not a definite shape. It's particles that stick firmly, but not rigidly, although the particles are held together by strong attractive forces and are in close contact with one another. They are able to move freely. Okay, I will show you an animation. This important characteristic over here. Let me see. Okay, so remember the solid oxygen that we have on the animation. And if we look for a liquid state, we got this. Okay, of course, it doesn't have a definitely shape. Okay, look at the atoms. The oxygen atoms can move with a little bit of freedom, right? Okay, so this particle mobility gives a liquid fluidity. Okay, that I don't know, it's a difficult word. It makes that a liquid flow, okay, and causes it to take the shape of the container in which it is stored, for example. Okay, excellent. Okay, let's go back to the presentation. Okay, for example, we have here, let me see, there is another one. No, this is not a liquid. No, it's not. Oh, for example, we have here the acetic acid, for example. It's a liquid. So look at this. The shape, the liquid shape is a cylinder. Yes, of course, because fill the container. And the last one that we're gonna talk about is the gas state. Okay. So we're going to talk about gases. A gas is a form of matter that not only flows to conform to the shape of its container, but also fill the entire volume of its container. So if you flow gas into a container, the gas will expand to fill the container. Okay. All right. Let's go and look at the animation. So we have here a liquid, but look at the gas. Okay. So a lot of oxygen atoms can move freely inside the cylinder. Okay. Fill the entire container. Okay. And they are moving around, I don't know, freely inside. Okay. They can move. But what happens if we cool the container, for example, put on some ice? Okay, that's very important because we are going to talk about this later. We have here a change of the state. Okay, for example, in this case, we have another solid. If we can put on some heat at the cylinder, the particles gain energy and can move a little bit more. So in this moment right here, we have a liquid, and if we can aggregate more heat, for example, we will get a gas state. Okay, excellent. That will be another lesson to study the physical changing of matter. Okay, but excellent. This is a gas. Compared to solids, for example, and liquids, the particles of gases are far apart. Okay, and remember this: gas and vapor do not mean the same thing. The word gas refers to the substance that is naturally on the gaseous state. But the word vapor refers to the gaseous state of a substance that is solid or a liquid at a room temperature. Okay? That's very important between gas and vapor. I wrote the entire paragraph over here. You can remember the difference between gas and vapor. Okay. So a gas has indefinite volume and not fixed shape, with particles that move independently of one another. Particles in the gaseous state have gained enough energy to overcome two attractive forces that held them together as liquids or solids. A gas presses continuously in all directions on the wall of any containers. We can see that on the cylinder. Okay. The particles of a gas are relatively far apart compared with those of solids and liquids. The actual volume of the gas particle is very small compared with the volume of the space occupied by the gas. Okay? I don't know, for example, you can see that on the animation, okay? the actual volume of gas particles is very small compared with the entire space on the cylinder. Okay. Okay, excellent. So this is those are the gas characteristics. Okay, very good. And the last state of matter that we're going to talk about is plasma. Okay, plasma is a form of matter that results when a particle or a lot of particles of a gas become ionized. Okay, become ionized and are broken apart into smaller charged particles. Ionization requires energy, such as that provided by an electric current in a neon or fluorescent bulb, for example. And the biggest example of plasma, of course, is our sun. Our sun in the center of the solar system is the principal source of caloric energy, for example, and is made of plasma. Okay, so ionized particles that can travel from the sun to the earth. Okay? That is plasma. Let me see, I have one picture. Okay. Oh, look at this. Yes, it's a toy. We can find it on the toy store, for example. Is a plasma ball. Okay. So look at this. We have plasma in a sphere, inside the sphere. Okay. For example. And of course, our sun is an example of the fourth state of matter called plasma. Okay. And we have here another one's example of plasma. Okay, I can download the image to share with you. Okay, example of plasma, and we'll show you a little bit bigger than the last one. Okay, for example, an aurora, a lightning, a plasma ball that I was talking about, a nuclear fireball, a neon sign outside, I don't know, for example, a supermarket, and welding arc. Okay. I don't know, for example, that a man can use in a construction, a building construction, for example. So are 6 examples of plasma. Okay. So excellent. We have finished the states of matter. So the next class, we're going to talk about the physical and chemical properties of matter. Okay. So bye.